Let's get adapted with logarithm function with this integral. So in solving this integral, we will be using logarithm function quite a lot, and while using that, I do hope that you will be somehow more familiar with this function. Yeah, let's begin. So how do we begin? So first of all, uh, we will try to write this as ln of 1 minus t by t, and then ln of 1 minus t dt. And there's a reason for this, because the integral of this function is just minus li2, yeah, and of a variable. So now if we integrate this with this as u and this as v, we get ln of 1 minus t, yeah, and this will just be minus li2 of t from 0 to x. Yeah. Oh, what happened? Okay. And then minus integral from 0 to x. Now our derivative of this is 1 by 1 minus t times minus 1, and integral of this is minus li2 of t, yeah, dt. Okay, so now if we evaluate this, we will have ln of 1 minus x with a negative sign in front, and then li2 of x, and at 0 those will be 0, so it doesn't matter. And now minus minus cancels out, minus integral from 0 to x. Now we have li2 of t by 1 minus t dt. Okay, so now basically we need to have just t in the denominator, yeah, because only then we will be able to use the same form again. So that's why for that we will substitute y as 1 minus t, yeah, and then try to solve it. We will have minus ln of 1 minus x, li2 of x, and then now with the substitution this will be from 1 to 1 minus x, and then li2 of, now this will be 1 minus y by y times minus dy. Now we can use minus sign to reflect the integral, and this can also be taken in terms of li2 of y using the Euler's reflection formula for logarithms, and that's why that will not be too hard. Yeah, 2 of x. Now this is minus integral from 1 to 1 minus, sorry, let me reflect the integral from 1 minus x to 1, and then li2 of 1 minus y by y dy. Now let us use the Euler's reflection formula for logarithm, which is li2 of y plus li2 of 1 minus y. This is actually equals to Riemann zeta of 2 minus ln of y ln of 1 minus y. Yeah. So now let us use this formula, and after using this formula it will be quite a lot easier to solve the problem. Yeah. So we will have minus ln of 1 minus x, li2 of x minus 1 minus x by 1. Now we know that this is just minus li2 of y plus Riemann zeta of 2 minus ln y ln 1 minus y by y dy. Yeah. Now we can basically use the negative sign over here and multiply this thing. This will be plus. Yeah, and over here that will be minus. This will be plus. Yeah. Now it's somehow easier. The last part will again be somehow complex, but others now it's easier. Minus ln of 1 minus x, li2 of x, yeah, plus. Now this is just li3 of y, yeah, and evaluated at 1 minus x and 1 minus, this is now Riemann zeta of 2 times ln of y, yeah, evaluated at 1 minus x and 1, and the last one will be plus integral from 1 minus x to 1 ln of y ln of 1 minus y by y dy. Okay, now for last one, again you need to use integration by parts. Yeah, and I will show you how. Also, let's evaluate the other terms. Minus ln of 1 minus x, li2 of x. Now li3 of 1 is just a part is constant, minus this is li3 of 1 minus x. Yeah, now this is ln of 1 is 0, so that will cancel, and now next one will be Riemann zeta of 2 times ln of 1 minus x. Yeah. Okay. Now let's use integration by parts for this one, and let us say that ln y is u and this one is b. Then we get ln y times, that will just be minus li2 of y. Yeah, this is going from 1 minus x to 1. Okay, minus integral from 1 minus x to 1. Now this is just 1 by y, and this is minus li2 of y. Yeah, dy. Now minus minus cancels and this becomes plus. Now this is also easier to evaluate. Yeah, minus ln of 1 minus x, li2 of x, plus Riemann zeta of 3 minus li3 of 1 minus x, plus Riemann zeta of 2 ln of 1 minus x. Now at 1 this is 0, we need to evaluate at 1 minus x, so minus, and minus minus would be plus, so plus ln of 1 minus x, li2 of 1 minus x, and now this is just li3 of y. So again li3 of 1 means Riemann zeta of 3 minus li3 of 1 minus x. So now we are at the last step. Solution will be now minus ln of 1 minus x, li2 of x, and 2 times Riemann zeta of 3 minus 2 times li3 of 1 minus x, plus Riemann zeta of 2 ln of 1 minus x, plus ln of 1 minus x, li2 of 1 minus x. This should be our answer, but let me check first. Yeah, and if it's incorrect I have to make a video again. Minus li2 of x ln of minus x, plus 2 Riemann zeta of 3 minus 2 li3 1 minus x, plus Riemann zeta of 2 ln 1 minus x, plus ln 1 minus x li2 1 minus x. Yeah, this is the correct answer. So in this problem, the flow of the problem was, first of all, we used integration by parts and got Li2 over here, and then over here we had Li2 of 1 minus I, so we had to use Euler's reflection formula, and then these two were easily integrable. And now for this one again we used integration by parts. Now there was a simpler version where you could use the properties of Li, and yeah, and then it was solved. So we just used the properties of logarithm and the reflection formula. That was it, integration by parts. Hope you enjoyed the integral. Thanks for watching, and also thanks to Zaid Al Yafai and his book Advanced Integration Techniques for this problem. Look forward to seeing you in the upcoming videos too.